Okay, so it says work with a partner in chemistry. pH is a measure of activity of dissolved hydrogen ions. Liquids with low pH values are called acids. Liquids with high pH values are called bases. Find the pH of each liquid. Is the liquid a base, neutral, or acid? All right, so let's see. For the lime juice, it says 0.01. Now, if you notice, when we look over here, they're all in scientific notation, right? So we need to figure out what is ours in scientific notation so we can put it over here. Okay, so if you remember, actually, if you look at this, it has ones for all of them, and look at all of ours. Ours are all ones. Okay, so we need to put it so it's 1 times. So if we look at that, we're going to say 1 times 10 to what power? Okay, now basically you can look at this as being going backwards. So we're going backwards. We're saying, what can I do now to this so that it becomes this? And if I look at it, I want it to, like right there's the decimal, right? Right there's the decimal. Right there, right after the 1. Okay, I want it to go back 2 places to the left, right? Because then it'll match that if I have it 2 places to the left. All right, so is it 2 places? Yeah, because if I go past the 1 there, that's 1, and then another place, and then there's the decimal, and then it looks exactly the same. And I just went 2 places to the left, which means my exponent is going to be -2, right? Because that means it's going to go 2 places left, because it's going to make it smaller by 2 places. So that means the lime juice should be 10 to the -2 right here. Okay, so this is where we're going to put the lime juice. So that's pretty acid, right? If we look at it, it matches over here with the acids. Okay, so we're going to call that one an acid. All right, then we've got the egg. That's going to be 1 times 10 to what power? Well, let's see here. I need to move it over. Oh, we got to count that. Let's see if I can make this bigger here. Here we go. Look at that. We got to count this, right? So how many places do I move it over? Remember, our decimal's right here. So technically the decimal's right there. And I got to say, how do I get it so it's back there? All right, so let's count that. So it's right here. So we go 1, 2, 3, 4, 5, 6, 7, 8. 8 to the left. Okay, that's how we're going to get that one. 8 to the left, and if I look at that, it's 10 to the -8, and if I look over here, this is 10 to the -8 right there. Okay, so this one's at an 8, and that looks to be a base, right? The only neutral one is right here, so that's just into the bases. So we'll call this one a base. Okay, now we have distilled water. So that's going to be 1 times 10 to what power? And so once again, let me make that bigger so we can actually move it over. The decimal's here, right? Isn't that where the decimal is? And remember, I'm trying to get it, so how do I get it to there? All right, so we count 1, 2, 3, 4, 5, 6, 7. So my exponent is -7. And then we look at our chart, and it says -7 is a neutral. So the water is a neutral. Okay. Ammonia water. So we've got 1 times 10 to what power? Again, we're putting the decimal here. How are we getting back to the original? So we'll go ahead and make it bigger. And ammonia water, let's count it over. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So -11, because we went to the left, it's -11. And that is going to be, well, let's look at it. -11 is a base. Okay, so ammonia water is a base. Okay, keep on going. We've got tomato juice. So again, it's going to be 1 times 10 to what power? And how do we get it back to the original? So let's make that big. Okay, and so we go over right here. We go 1, 2, 3, 4. So that'll be -4. All right, which is an acid, right? If I look at my thing, 10 to the -4 fits in the acids. So let me label that as an acid. And then hydrogen acid, we've got 1 times 10 to the what? Well, look it's already a 1, so I go 10 to the 0. And that means it's right here as an acid. And guess what? It even says acid in its name, so I guess we were good. All right. Now, writing numbers in scientific notation. Okay, there's 2 things we're looking at. One, we want to look at this, One, we want to look at this number and we want to say, okay, I need to put the decimal where it belongs. So I put the decimal so that it's after the first digit, that first real number besides the 0. I need to put the decimal after that. Okay, and then it says count the number of places you move to the decimal point. All right, and remember, we want to say, how do I get back to the original? So this is always the instructions on how you get to the original, and that can sometimes be the tricky part. Usually people can get the 3, but they're not sure if I should put a positive 3 or negative 3, and it's all about getting back to the original. So if we put the decimal here, how do you get back to the original here? And you move it to the right, you're making it bigger, so it's a positive 3. So let's just look at some examples here. Okay, so we are supposed to match each planet with its distance from the sun, then write each distance in scientific notation. Okay, I'm actually going to do this. I'm just worried about scientific notation. I'm not really worried about matching them. So let's just make this nice and big here. Okay, so our first job, let's write them so that the decimal's in the right spot. So here I have a 1 and an 8, so I'm going to write 1, 8. I need the decimal to be right after the 1. I need one thing in front, times 10 to what power? Now we just put the decimal here. Remember, the power, the exponent, is telling us how to get back to the original, and the original had the decimal right here. So you'll notice I'll be going to the right, which means I'm making it bigger, so it'll be a positive, and then we start counting. Okay, so we've got 1, 2, 3, 4, 5, 6, 7, 8, 9 times to the right, so that is a positive 9. Okay, the next one, we have 67 million. Well, that's going to be 6.7, because I need one decimal in front, times 10 to what power? Well, we put the decimal here, but the original was here, and I'm trying to figure out how to get back to the original, so we have to go to the right, which means positive, right, because to the right makes it bigger. And we got 1, 2, 3, 4, 5, 6, 7. So it's an exponent of a positive 7. Okay, then we have the next one is 8.9 times what power? And so we have 8.9. So I put the decimal here, and I'm trying to get back to the original. So I'm going to the right, so it's positive. We've got 2, 3, 4, 5, 6, 7, 8. So it's times 10 to the positive 8. On the next one, we're going to have 9.3 times 10 to what power? Now we put the decimal here, but we want it to be here for the original, so we're moving it to the right, so it'll be positive 1, 2, 3, 4, 5, 6, 7. Positive 7. All right, so you can actually go through and do a bunch of these, right? We've got 1.4 times 10 to the... Okay, we put it here, we want it here. To get it there, we need to move it to the right, so we positive. So if we count it out, we're actually going to get moving it 8 times to the right. Then we have 2.8 times 10 to the, and we got to figure out we want to get it there, but we moved it here, so we have to move it 3, 6, 9 times to the right, so it's positive. Then we have 4.8 times 10 to the, okay, we moved it here, but we want it here, so we have to move it to the right 8 times. And the last one, we have 3.6 times 10 to what power? Okay, so we have a point right here, and we want to move it right here, so that's going to be 7 to the right. Yep. Now, it says Google purchased YouTube for this much money. Write this number in scientific notation. So we have to put 1.65. Remember, after the decimal can be as many numbers as you want. So 1.65 times 10 to what power? And now we need to look at counting the decimals. We put the decimal here. We want it to be here, which means if we move it to the right, it makes it bigger, positive. So we've got 3, 6, 9 places. Okay. And then we have this one. Now this is going to be a little bit different. So we're looking at this number right here. I need to write as 2.68. Again, I need one number in front of the decimal, times 10 to the. Now, let's make this bigger so we can see it. We put the decimal right here, but we want it here. So we have to go this way. Okay, so when we take a decimal from here, and we move it here, we're making the number smaller. So we need our exponent to be negative, and then we count. Okay, so we have 1, 2, 3, 4, 5, 6 places. So our exponent's going to be negative 6 on that one. All right, so then it's a matter of just, keep on practicing these things. Why don't you go ahead and pause, and then you can do all of these. And now I'll tell you the answers. Okay, so for 50,000, we have 5.0 times 10 to the, and I'm moving it to the right, I'm making it bigger, and I'm moving it to the right 4 places. For number 4, I'm going to have 5.0 times 10 to the, I put the decimal here, but I want it here, so I'm going to move it to the left 3 places. That means a negative 3 because I made it smaller. Okay, on the next one, I have 2.5 times 10 to the, and I have a decimal here, and I need to move it here. I need to move it to the right, making it bigger, and I move it 7 places, so it's a positive 7. For 5, I have 3.3 times 10 to the, put the decimal after the first 3 there, so I put it there, but I need it to go backwards, so I need it to go minus. And then we count 1, 2, 3, 4, 5, 6, 7 places, so negative 7. And then for those last two, we have 6.83 times 10 to the, I put the decimal here, I want it here, moving it to the right, making it bigger, and I need a positive 2. And then 5.06 times 10 to the, I put the decimal here, I need it to go to the left, so it'll be negative, and I move it 1, 2, 3, 4 places, so negative 4. All right, now, it's just a matter of practicing. And so this is what we did in class. An album has sold 8,780,000 copies. How many more copies does it need to sell to receive an award? Okay, an album receives an award when it sells 10 million copies. So you'll notice all of the answers are in scientific notation. So first off, let's see how far away we are. So let's go with 10 million. Take away the 8,780,000. So we'll subtract those. This is a 9, this is a 9. So there we go. Now you'll notice they all have 1.22, so it's 1.22 times 10 to the, and now it's decimals here, and I want to move it there, so it's a positive. So I know it's not A and it's not B because those are negative. I want positive. And then I have to look at how many I go. So 1, 2, 3, 4, 5, 6. Okay. And then the table shows when the last 3 geologic eras began. Order the eras from earliest to most recent. So we want oldest to newest, right? So biggest to smallest, basically, because the bigger the number, the longer ago it was. Now, if we look at this, you'll notice that this one only moves at 7 places, and these two move at 8 places. So this is the youngest. So this is the last one that we want, 6.55 times 10 to the 7th. Okay, then we got the other two. They're both going to be times 10 to the 8th, so we can write that. Now, since they're both times 10 to the 8th, we can just look at these numbers and say which one's bigger. The 5.42 is bigger, so that's the older one, because remember, the bigger the number, the longer ago it was. And then 2.51 is the next one. All right, so here's your homework for Monday. Hopefully you can do this. Remember, just be very, very careful. When you're putting it in scientific notation, you are saying, how do I go back to the original? You are making the rule. And so your rule has to say, how do you go back to the original? And that's how you know whether it's going to be positive or negative. Remember, you make it bigger when it's positive, make it smaller when it's negative.